Welcome to Spark 101 Voices, where we have stimulating conversations around STEM learning and STEM earning. This will be the first of two episodes where we talk to Andre Jones. Andre is an experienced aircraft professional. He has been a chief aircraft inspector, is a certified airframe and power plant mechanic and inspector, as well as a non-destructive testing aircraft inspector. Andre was also in our Spark 101 Career Snapshot, highlighting careers in the aerospace industry. Andre, welcome to Spark 101 Voices. I mentioned in the intro a little bit of your background, but why don't you tell us in your own words?
Okay, absolutely. I obtained my airframe and power plant certificate close to 20 years ago and worked in various areas of the aviation industry, anywhere from an A&P mechanic to a traditional inspector, as well as a non-destructive testing inspector. And I've also worked in quality assurance as a manager as well as a chief inspector for many years.
When you said airframe and power plant, when you talk about power plant, what does that mean in aerospace?
Power plant means you can work on engines. Specifically, the airframe portion means that you can work on anywhere else on the aircraft, so the empennage, fuselage, wing components, and the wing, landing gear, etc. But the power plant means that you have a license to specifically work directly on an engine. You can overhaul the engine, swap out components, do testing on the engine capabilities and things like that.
So basically clearing that up for me more. Airframe is everything on the plane except for the power plant. Power plant is specifically engines. So you can do pretty much anything on an airplane.
Yes. Tip to tail.
Okay. And how common is it to have that much certification?
It's quite common. Some people decide that they don't want to work on engines. They just want to do, let's say, things like sheet metal. They want to have a specific trade. And others, they go through an entire program to get more experience so that they can have they can be versatile.
How do you get into something like this? You were talking about it today. Young people wanted to get into this. Would they go to a program that has both? Would they specialize in one before the other? How does that work?
They would go into a program that has both, but based on the structure of the program, you have to complete one area first before you can get to the power plant section. I do believe now that one could choose one or the other, so you wouldn't have to go through a complete program. Some people want to complete one half of the program first so they can start working, and then complete the other half while they're already working for a company.
Okay, and would a company, in your experience with that, would a company pay for them to do that? So could I go and get my airframe certification and work for Southwest or another company, and would they have programs, or would they help me get that additional certification?
Absolutely. There are there are multiple aviation companies. One that comes at the top of my head is PSA Airlines. They offer even a toolbox for new mechanics to start working, and while they're working, they can contribute to them achieving their next certification or the next certificate.
So basically, if I don't have to dump a lot of money into school right away, I can go and get a minimal training and probably get a job pretty swiftly, work with that company so that they then help me continue on with my career and my certifications.
Absolutely. And again, the younger generation, they are doing it that way because they want to get to work as quickly as possible. So I know and have met several aviation students that have finished their airframe and they're getting to work so that they can, of course, develop more skills on the job training while they continue their education.
So I know you have all kinds of certifications and how incredibly talented you are, but I want to go to something you mentioned before, which was non-destructive testing. And when I met with you and was in your hangar, you were explaining to me a lot of what that is and what that means. Can you talk to me a little bit again about what is non-destructive testing and why is it important?
Sure. So non-destructive testing is extremely important in aviation because it allows a technician or an inspector to do an investigation on the aircraft structure. So, of course, aircrafts are painted with, a lot of paint. And in order to find a defect, you would have to use a special skill or special tool to look through look through the outer covering or the shell of the aircraft. So you have to go a little bit deeper. And non-destructive is the perfect way to do that. I like to compare it to a pregnancy. So, when a woman is pregnant, she would go to the doctor and the doctor would do an ultrasound on her to look at the baby and see the movements and listen to his heartbeat and things like that. Well, you can do the exact same thing on an aircraft.
So what are those tests that you can do?
Tests like it's called liquid penetrant or a dye penetrant, where you can apply a dye on a piece of metal, and so that dye would penetrate and it would go into a crack. So it's a process. You would, of course, apply the dye and then spray a coating on it, and when the dye permeates through the metal, you can identify the defect. So that's one way. There are several, at least 7 or so ways. Liquid penetrant is one, magnetic particle inspection, eddy current inspection, ultrasonic inspection, radiography inspection. Of course, visual inspection is also non-destructive, and sonic and resonance inspection.
And do you hold certifications in any of those?
I hold certifications in all except the sonic resonance.
And is there?
This stuff is really fun, Russ. I just want to tell you, when I started learning about material sciences, I had no idea that it would be this exciting, and it's a little bit. I'm not really sure how to say this, but you have to be a little bit of a geek to really get into it. But it's a lot of fun.
So what about it? What about it do you enjoy?
Well, it's like you're a private investigator. You are looking for things that could cause damage to an aircraft. So in a way, you want to find these defects or possible defects before the aircraft is released with passengers, so to say, okay? So when I'm doing an inspection on, let's say, a wing, I want to know if that wing has damage, or it could be a landing gear. I want to know if the aircraft has had a hard landing. Did anything shift in that landing gear? Was there a hairline crack that could, after a landing one more time, that could shatter? So you really want to find these defects to prevent damage to the aircraft and, of course, damage to people, harm to people.
So when you're looking for those defects, you don't just go to a plane and start, or an aircraft and start and go, wing to wing or whatever, looking for the defects. How do you mentioned a hard landing. Do you get a report that says this vehicle has had a hard landing, so look for this? How do you know what and where to inspect?
Aircraft inspections are typically based on hours or flights. So the aircraft could come to your service center with those hours, and with that, there will be, according to the aircraft maintenance manual, there will be inspection criteria which guides you to do that type of inspection. However, the pilot could also report they had a hard landing. So in that case, we would document that inspection in the logbook based on a pilot's report.
So you're going to take a checklist basically from the manufacturer of the aircraft that says, kind of like an oil change type thing, or what people might do with a car, and it has this many miles, check this, this, and this, check the brakes, do this type of thing to make sure it's okay. You're going to have something similar just so we can compare it. So, kind of understand it a little bit more. You're going to have this similar type of checklist for your aircraft and do all of these things at so many miles. And then if a pilot says something, you're going to know because of your expertise, oh, this happened, so go and check and make sure that we don't have any stresses or damage to different parts of the plane.
Exactly. And another good example of that is a lightning strike. So if the pilot has flown through a storm, they are aware that the aircraft was hit by lightning. Upon arrival, the pilot would document that in the logbook and tell the inspector, we were hit by lightning. Please conduct a lightning strike inspection on the aircraft.
If I'm a passenger on a plane, am I going to know it was hit by lightning?
You would not know, because the aircraft is designed to dissipate high voltage. So there are components on the aircraft called static wicks, and the electricity that flows through the aircraft would exit the aircraft through these static wicks. However, because the aircraft is designed, it's assembled by sheet metal and rivets. Those rivets may also be affected. So that's when the non-destructive testing comes in.
So really, you're going back to what you've learned about material sciences to know that, okay, if lightning came through, it could have done this to the aircraft. I should check for these things, and then do one of your many non-destructive tests to see where damage may have occurred.
Exactly.
Okay. Is there a test that you like, or that you've found that you geek out on, or are a little bit more, mad scientist on than others?
The current inspection as well as the ultrasonic, those are my two favorites, because you're sending a signal through a piece of steel, and if a defect is found, you could literally watch a screen, watch the wave on a screen change. So let's say there's a flat line on your screen and you're running a probe across a rivet that has been affected, or there could be a crack next to that rivet, then on your screen, you would see a spike. So, when you're performing an inspection and you're looking at the screen and you're holding the probe a certain way, and you see that spike, that's like hitting a jackpot, so to speak. So then you could do a further inspection once you find a defect.
Okay, so I would take that for a minute for me. If you find that there's a defect, you do your eddy current test and you find there's a defect, is eddy current going to tell you about like the sheet metal of the aircraft, the frame of it, and then you're going to have to repair it? Or are you looking at other things other than just the surface?
Well, you're just looking at the surface at this time. Once you find a defect, you would then go and, let's say, sand off the paint so you can expose the sheet metal, and you can identify if there was a crack, how deep the crack was, and if the crack affected other areas of the aircraft. So the aircraft, let's say the skeleton of an aircraft is made up of different beams and other structures. That crack in the surface of the aircraft, the outside surface, could penetrate a substructure. So again, going back to being an investigator, you would, start on the outside and then go on the inside and look for more defects.
You mentioned before, you said a technician or an inspector. So in aircraft mechanics and aircraft maintenance, is there a difference between a technician or an inspector?
Technician is the person that would typically remove and replace a component or test a component, testing an electrical component or an avionics piece of equipment or anything in the cockpit. Your inspector is your validator. So your inspector works alongside with the mechanic and ensures that the mechanic followed all the steps required in the aircraft maintenance manual or inspection report and validates, yes, we followed all these steps, and in accordance with the aircraft maintenance manual, this test is either not operative or it works perfectly.
So can you talk to me a little bit about that? Because normally I would think that, what I'm familiar with in taking my car to a mechanic or something like that, or having maintenance done on my house, somebody's going to come and they're going to do it and they're going to say it's done, or I'm going to take it into a shop and they're going to say, okay, this is what's wrong. I fixed it, pay me money, here's your car and go. That sounds like it's different for you working on an aircraft. You kind of have two people who are working. How is that? How does that work? Why is that?
Well, you're exactly right. There is a level of redundancy because we are talking about the safety of personnel or persons on the aircraft. So it's important to, one, follow the aircraft maintenance manual or any publications that's guiding you to do a certain task, and then have a second set of eyes to look at the work that was being performed.
Is that something that is just in the shops that you've worked on, or if I'm taking a commercial flight, do I know that there's been a technician and an inspector fixing and doing everything? Is that a universal thing, or is that just, I don't want to say in quality trustworthy shops, but in aerospace, is that how it's done universally?
It is pretty universal. However, if an aircraft is flying, let's say not to a repair shop, it may, let's say one aircraft is flying to multiple locations in one day. Well, when the aircraft goes to the second destination, there may have been an issue. On site, there may not be an inspector. There may only be a mechanic. In that case, these mechanics have layers of experience which would allow them to either perform the task as well as the inspection, or to defer the inspection to the next visit where there is an inspector.
What type of, you mentioned how you were geeking out and things like that in doing your inspection. Go to thinking about the different skills and skill set that you have and skills that you use. You've had multiple careers, I would assume, because you have your airframe and power plant certification, but you also have other certifications beyond that, right?
Yes. So in aviation, you don't necessarily need a degree unless you are pursuing upper management positions. The best thing for a mechanic to do is enhance his skills by obtaining certain certifications and inspection requirements. So one of the first things that I did was I took an inspection class, which taught me what to look for in an aircraft. Let's say when you are doing an initial evaluation. So when the aircraft first comes into the shop, what to look for there. And then I expanded that into the non-destructive testing certifications, which taught me a second level of inspection. And then from there, I went to several FAA courses, which taught me more about aircraft certifications, certifying parts, how to check traceability on parts being installed on the aircraft, how to check traceability on foreign parts on a foreign registered aircraft. So there's just so much to learn in aviation. That's why it's for any new student or at any age, someone going into a career in aviation, there's so much to learn. For me, I got bored a lot when I was growing up. And when I found aviation, I knew that this was the best career for me because there was so much to learn. And I can learn about avionics systems. I can learn sheet metal. I can learn non-destructive testing. I can learn planning, how to plan maintenance on an aircraft, how to provide logistics for the aircraft, how to order parts for the aircraft. There's just so many things to learn. That's why it's so exciting to be in this industry.
You didn't start as a mechanic. You started as an inspector.
I started out as a mechanic.
Okay.
But I was enthusiastic about learning more, and I had an opportunity to either become a lead mechanic or to become an inspector. And I chose to become an inspector because I felt like I learned a lot already being a mechanic, and I wanted to add more layers. I wanted to learn more about the aircraft, more than just testing equipment, running the engines, removing, replacing components. I wanted to learn every part of the aircraft, and as an inspector, you do that.
Okay. So my understanding would be you can be a mechanic, and then that is your airframe and power plant certification to work on a plane. There's different degrees of that. And then on top of it, you have mechanics who would become a lead mechanic, which I'm sure is a great career.
Absolutely.
But because you get bored easy, you decided, okay, I'm going to go to the inspection route. So then you started to learn all of those aspects. So that gave you a greater understanding of aircrafts as a whole?
Correct.
Okay. And you mentioned, and I want you to elaborate a little bit, you mentioned sourcing parts and figuring out foreign parts. Now, obviously, all aircraft's not made in North America, but why is that important to look at foreign parts and have that understanding?
The FAA, Federal Aviation Administration, has relationships or what we call bilateral agreements with foreign countries. In those agreements, it tells a U.S. certified mechanic, it tells us that in order to certify an aircraft with these components, you have to, let's say, have a two-part inspection or a dual release on the airworthiness tag. So there's more research that has to be done if you are performing maintenance on a foreign aircraft.
And is that because it's housed somewhere else and you need to make sure it's up to the regulations to fly in this country, or why is that?
These are based on safety standards established by the FAA and also the foreign government's airworthiness regulations. So each foreign country has their own aviation safety administration. And so they have rules that we also have to comply with. So again, the FAA has relationships with most countries, and so we would do research and understand what rules apply to that particular country that we're working on, the aircraft we're working on from that country, in order to maintain safety and airworthiness of the aircraft.
And can you look at an aircraft and tell what country it's from?
Yes. Every aircraft has a unique identifier. We call it a tail number or aircraft registration number. So you can look on either the tail or the engine cowlings and look at that identifier, And let's say you can go to Google and find out what country that aircraft is being registered in. So that being said, if the military was flying close enough to an aircraft in our airspace, they can look at the tail number and identify what country the aircraft is registered in.
And then for you, you would know, okay, it comes into your shop. It has this tail number, so it's going to be a US-based craft. So I'm going to work under this set of guidelines versus being an aircraft in Mexico or from China, that you're going to have a different set of guidelines. Still all the same as far as the mechanics that need to be done, but it's a different set of guidelines on how the parts go and the safety specs that you have to use.
Correct. And most importantly, the airworthiness release or the logbook entry has to be stated a certain way for it to be approved for return to service.
Who sees that logbook? Like, does it stay on the aircraft, or is this something that's kept virtually so that anybody can see it? How's that work?
It stays on the aircraft. It travels with the aircraft. It's basically the history of the maintenance performed on the aircraft. And there are also digital forms of the maintenance logbook, but it must travel with the aircraft for the life of the aircraft.
So if it lands in your shop and you see, hey, this looks like it's not right, what's going on? You can look in the logbook and say, oh, they made a mistake here, or they already looked at this and saw they did a non-destructive test and saw that there wasn't anything here, but there is today. So, does that help you in inspecting and being the the kind of mad scientist, private investigator finding the issues in an aircraft?
Absolutely. It's really important, Russ. I'm glad you brought that up, because parts are being modified, enhanced. They're to perform better. Parts have different modifications, and the part number would change. So the primary part number may stay the same, and you may add a dash number to it, a -1 or a -2. So if that component failed on an aircraft and you are doing let's say an accident investigation of some sort or an incident investigation, you could determine based on the logbook entry if the right component was installed on the aircraft with its effectivity. So again, what I was saying earlier, a mechanic and inspector must know how to perform a traceability on a component that's installed. So they need to know how many hours are on that component, if it's brand new, if the component has been overhauled, if it's been repaired, if it has the right modification number. So there's a lot that goes to replacing a component on an aircraft. It's not just cut and dry. You have this model aircraft and this is the part that goes to it. So there may be an extension. Okay, well, the manufacturer has modified this component to operate better, so we add a dash number. Now, you can install this part number on this aircraft if it meets a particular set of rules or criteria. Again, you can probably hear the excitement in my voice because you have to do all this research in order to make sure it's right.
I mean, would it ever happen that whenever you're doing something like that, so you have, part X, and this part you're going to need to replace, but a company comes out and says, hey, this is part X, but it's X-1 because it does the job better. So you put it on an aircraft and it turns out that it's the right part for the fit, but because it's doing the job better, it actually created more stress on something that
it's possible. Yes,
okay.
It's possible. And you have to know also, or one has to know that all these parts have to be certified by the FAA. A person cannot create a better component in their garage and try to sell it to an aircraft manufacturer and say, you know what, I did better than you, my part works more efficient, and you should use it. You should buy it from me, right?
So you're not creating your carburetor in your garage that's going to fit on your Rolls-Royce engine.
Correct.
Okay. We will hear more from Andre in our next episode of Spark 101 Voices. To learn more about the work that Andre does, check out the Spark 101 Aerospace Industry Career Snapshot on spark101.org. Thanks again to our guest today on Spark 101 Voices, and thank you listeners for joining us. You can connect with me and the whole Spark 101 team on all the socials by searching Spark 101 STEM, or visit us directly at spark101.org.